Airframe and system description. This video will cover the following topics: airframe, flight controls, instrument panel, seats and safety harness, doors, electrical system, Pitot-static pressure systems, brakes. A dedicated video on the fuel system and engine will follow this one. Airframe. The Tecnam P208 airframe can be divided into the following main groups, as shown below: wings, fuselage, empennage, landing gear. Wings. Each wing is connected to the fuselage by means of two bolt attachments and a single strut brace on each side. The wings consist of a central light alloy torsion box. A light alloy leading edge is attached to the front spar, while the slotted flap and frise aileron are attached to the rear spar through two hinges each. The torsion box is made up of a front and rear spar, which form its vertical walls. A series of ribs and wraparound panels complete the structure. The front and rear spars include fittings for the wing-to-fuselage attachment. The ailerons and flaps consist of an aluminium spar connected to a formed sheet metal leading edge and metal ribs, with an aluminium skin enclosing the aileron structure. The fuel tank is integrated in the wing box. Fuselage. The Tecnam fuselage is primarily made of carbon fiber composite materials. It consists of two main shells that are later assembled by bonding the two main bodies and the composite floor together, and by adding aluminium stiffeners that enable the attachment of the main landing gear, seats, wings, and instrument panel. In this configuration, the fuselage and vertical fin form a single integrated structure. Empennage. The horizontal tail is an all-moving type. The stabilizer and elevator form a single continuous surface called the stabilator, which rotates to achieve the desired pitch setting. The stabilator structure consists of an aluminium spar and ribs, with aluminium skin panels riveted to these components. A trim tab provides stick force adjustment and longitudinal compensation. The vertical tail is part of the composite fuselage. Vertical fin is made up of a twin spar, and all the structure is carbon fiber. Rudder, providing directional control of the airplane, is made up of aluminium alloy. The rudder is connected to the vertical tail at two hinge points. Landing gear. The main landing gear consists of two special steel leaf springs positioned crosswise to the fuselage. These steel leaf springs are attached to the fuselage structure through two pairs of machined aluminium beams. The wheels are mounted cantilever style on the gear struts and are equipped with hydraulically actuated disc brakes controlled by toe pedals. A pivoting nose gear is attached to the firewall reinforcement plate. The hydraulic shock absorber is mounted on the upper machined component and directly connected to the nose landing gear structure. Flight controls. The main flight control system regulates the airplane in three axes. All primary controls, ailerons, rudder, and stabilator, are manually operated by a conventional control stick and rudder pedals, pulleys, cables, bell cranks, and rods. The secondary flight controls consist of a pitch trim system and a flap system. Complete dual controls are provided for pilot and co-pilot. Longitudinal control acts through a system of push-pull rods connected to the control stick and moving the stabilator, whose anti-servo tab works also as trim tab. Longitudinal trim is performed by the trim tab located on the stabilator through an electric actuator controlled by the pilot or co-pilot by a switch located on the control stick. Another switch on the instrument panel gives full authority to pilot or co-pilot control switch. An analog trim indicator provides information about the surface position. In case of a trim control runaway, a trim disconnect switch is available on the instrument panel. Aileron control is of mixed type with push rods and cables. A cable control circuit is confined within the cabin, and it is connected to a pair of push-pull rod systems positioned in each main wing, which control ailerons differentially. Flaps are extended via an electric servo actuator controlled by a switch on the instrument panel. Flaps act in continuous mode. The indicator displays 3 markings related to 0 degrees, takeoff and landing, full positions. A breaker positioned on the right side of the instrument panel protects the electric circuit. Instrument panel. The instrument panel is divided into 4 areas. The left area contains the primary flight instruments and pilot situational awareness instruments, a chronometer, and the pitch trim indicator. The right area contains the engine and moving map indicators, an analog backup CHT indicator, and the circuit breaker panel. The central area contains the navigation and communication instruments, the transponder, warning lights, the trim cutout switch, the left or right trim selector switch, and the annunciator panel with the following lights: electric fuel pump on, green; low oil pressure, red; low fuel pressure, red; alternator fail, amber; and pitot heat operation light, green or amber optional. The lower left-hand portion of the instrument panel contains the ignition key, master and generator switches, emergency fuel pump switch, avionics master switch, pitot heat switch, optional, and carburetor heat knob. The lower central portion of the instrument panel contains the throttle, 2 analog fuel quantity indicators, and the fuel selector valve. The lower right-hand portion of the instrument panel contains the flap indicator and control, the cabin heating knob, and the nav, landing, and strobe light switches. Carburetor heat. Carburetor heat control knob is located lower LH portion of the instrument panel. When the knob is pulled fully outward from the instrument panel, carburetors receive maximum hot air. During normal operation, the knob is set in off position. Cabin heat. The cabin heat control knob is positioned on the lower right side of the instrument panel. When knob is pulled fully outward, cabin receives maximum hot air. If the outlets are kept closed, hot air only performs windshield defrost. Vents are located by the rudder pedals. If necessary, outside fresh air can be circulated inside cabin by opening the vents on the door's windows. Although the layout is generally the same across the entire fleet of aircraft used in ALO Swiss Academy, there may be some variations depending on the model and year of manufacture of the aircraft. Before flying, it is essential that you become familiar with the layout of the aircraft. Spend some time looking at pictures of the instrument panel or visit the airport and ask to see the actual aircraft. Seats and safety harness. Each seat is horizontally adjustable. They are mounted on 2 parallel tracks attached to the compartment floor structure, allowing the seat to move forward or rearward. The seats are built with a light alloy tubular structure and synthetic material cushioning. A lever located on the lower right side of each seat allows for adjustment according to the pilot's size. The aircraft features 3 fitting points for safety belts equipped with waist and shoulder harnesses adjustable via sliding metal buckles. Doors. The Tecnam cabin has 2 doors located on each side of the fuselage. The doors are made of carbon fibre and fiberglass. External visibility for the crew is ensured by 4 side windows, 2 on each side, and a wide windshield that provides both the pilot and co-pilot with excellent visibility during all flight maneuvers. The door closing system consists of a simple latch positioned at the rear part of the door. Locking is ensured by a safety mechanism that includes a security lock located at the top of the door. The doors are also equipped with a restraint system designed to prevent damage to the fuselage in the event of strong winds. Electrical system. Primary DC power is supplied by an external alternator with a 14-volt output, rated at 40 amperes at 5800 RPM. During normal operation, the alternator also recharges the main battery. Secondary DC power is provided by the main battery, which supplies energy to the essential electrical loads in the event of an alternator failure. A second battery, used only during engine startup, is installed as a buffer battery. While its primary function is to assist during engine start, it can also provide additional electrical power in case of alternator failure or total electrical system loss. This battery is controlled by the master switch and is connected exclusively to the Garmin units. It is installed beside the main battery in a dedicated compartment. Switching between power sources, alternator and main battery is automatic, requiring no pilot action to activate the alternate power source. For ground maintenance or engine startup, an external power socket is provided. Both the alternator and batteries are connected to the battery bus, supplying power to the aircraft's electrical equipment. Each electrically fed instrument is connected to a dedicated circuit breaker, which protects the cable from the battery bus to the associated electric equipment. Warning: if the ignition is in the position LR or both, an accidental movement of the propeller may start the engine with possible danger for bystanders. The aircraft is equipped with an electrical stall warning system consisting of a sensor located on the right wing, leading edge connected to a warning horn located near the instrument panel. External lights. The external lighting system consists of the following equipment: nav lights, 2 position lights that provide aircraft flight direction identification; strobe lights, flashing lights that enhance aircraft visibility to prevent collisions. These, along with the nav lights, are located on the wingtips. Landing light provides ground reference during final approach, touchdown, ground roll, and takeoff, and illuminates major obstructions in the aircraft's glide path or on the runway at night. It is installed on the lower engine cowling, in front of the nose landing gear leg. All mentioned lights, whose circuits are protected by dedicated breakers, are activated by the related switches on the right lower area of instrument panel. Some aircraft may be equipped with a taxi light to be used during taxiing. It's just the landing light illuminated with less intensity. Pitot-static system. The TECNAM's airspeed and altitude indicating systems are connected to a pitot-static system consisting of a total pressure (Pitot probe) mounted on the left wing strut and 2 static pressure ports connected in parallel, located on the left and right sides of the fuselage near the engine firewall. Flexible tubing connects the total pressure and static ports to the primary analog instruments, the airspeed indicator and the altimeter. The Garmin G3X ADE-Chores GSU-73 unit, installed in the rear section of the fuselage near the battery, functions as the air data computer for the Garmin G3X suite. It is connected to both the static and total pressure lines, providing the system with airspeed and altitude information. Brake system. The TECNAM is equipped with an independent, hydraulically actuated brake system for each main wheel. This is the aircraft's only hydraulic system. A master cylinder is attached to each pilot's rudder pedal. Hydraulic pressure, applied through the master cylinders, is transmitted via lines connected to the brake calipers. A parking brake valve, located on the cabin floor and operated by a knob on the cockpit's central pedestal, intercepts the hydraulic lines, once pressurized by the toe brakes, to keep the brake pads clamped around the main wheel discs. Brakes can be operated from either the pilot's or co-pilot's pedals. A single vented oil reservoir supplies fluid to the pilot side master cylinders, which are connected to the co-pilot's cylinders via flexible hoses. In the next video, the engine and fuel system will be covered in detail.